Alrighty, in this video we are going to be talking about antiderivatives of inverse trig. The two main important ones that you'll need to know would be inverse sine and inverse tangent, because that will be on the AP exam. Now, inverse secant, you will not see it on the AP exam, but you'll probably see it on the test. So that's going to be a lot of fun. Now, you also see that in our table above that we have A's and U's. A is going to be your constant, and then U is going to be your function. In addition, as a disclaimer for these types of problems, we have learned a lot of techniques in terms of U sub, manipulating U sub, and then we're going to be talking about inverse trig. So some of these examples might look like you might use inverse trig, but plot twist, you won't. AKA, you're going to have to use other anti-differentiation techniques that we learned in the past semester. But looking at number 8 here, notice how I have a plus sign, so I know that it's going to be inverse tangent. What I need to do is figure out what my A value and U value is. Now notice how with inverse tangent I have A squared plus U squared. So that means that my constant is going to be 3, and then my U is going to be 2x, because that's just the square root of 4x squared. Now, I'm going to be using U sub. So now I have du being 2 dx. And then I am going to go ahead and change this so that is in the form of this right here. So now I have the integral of 1/2 to a squared plus u squared du. The 1/2 and the 2 will cancel out. So now I have 1 over a squared plus u squared du, which, plot twist, is inverse tangent. So now I have 1 over a inverse tangent of u over a plus c. And then we are just going to plug in u and a based off what we know. So a is 3, and then u is 2x. So that is my final answer. Alright, same thing for number 9 here. We have the integral of 3x over the square root of 1 minus 9x squared. Since this is a square root and it's a minus sign, it looks like inverse sine, so let's go ahead and look at a and my u. If I have a, that's going to be 1, and then if I have u, I'm going to have 3x. Now if I do that, I get du to be 3 dx. If I were to use u sub, I have a problem, because I'm going to have 1 over 3, 3x, 1 minus, not 1, a squared minus c squared du. The problem is I have an x right here, so I can't use inverse trig. Instead, what I'm going to be doing for number 9 is just using regular u substitution, which kind of makes sense because my u here is just 1 minus 1x squared, and du is equal to negative 18x dx. Notice how here, the x right here and the x right here is going to cancel out, which is what we want. So now I have negative 3 over 18, 1 over square root of u du. We know that the integral of u to the negative 1/2 is upper power and divide. So negative 3 over 18 upper power divide. Simplify this a little bit. So negative 6 over 18, which is going to be negative 1/3. U to the 1/2 plus c. And then I get 1 minus 9x squared to the 1/2 plus c. See how that one I did not have to use inverse trig there. So try using u sub And the reason why is because notice how I have an exponent that is 1 less than my u value here. Earlier we had u to be 3x, and if I did do u, I got 3, so that wouldn't have worked. Okay, same thing with number 10. Notice how I have a square root, and then notice how I have a 2x squared. So this kind of looks like inverse secant. My u is going to be 2x squared, and then my a value is going to be 6. This tells me that du is going to be 4x, so then I have 1/4 the integral of, the x will cancel out here, 1 over u squared minus a squared du, and that is going to be inverse secant. Now remember that that is going to be the absolute value of u over a. Let's see, and then don't forget about the 1 over a, which I did. In this case, your a is going to be 6. So then I have 1 6 right here. You are going to simplify this a little bit. So 1 over 24 inverse secant of 2x squared over 6 plus c. Now, remember that 2x squared is always going to be positive. So technically I could drop the absolute value and simplify her a little bit and get this lovely thing right here. Okay, number 11. You might think, oh, I have x squared plus 1, so I might use inverse tangent. Plot twist. No, because I can simplify the numerator to be x squared minus 1, x squared plus 1, x squared plus 1. The x squared plus 1 cancels out. I'm left with x squared minus 1, which gives us 1/3 x minus x plus c. Now, obviously, this one wouldn't have been inverse tangents because then your u would just be x, and then your du would have been 1, which then would not cancel out with x to the 4th. 8 through 11 were indefinite integrals. For 12 and 13, we have definite integrals where we are going to have to change our bounds. So make sure that whenever we change our bounds, we substitute it in terms of u. So for number 12 here, I have 4 over x squared plus 9. I am going to think about what this looks like. This looks like an inverse tangent, where u is x, and then a is 3. Now if u is x, then du is just going to be 1 dx. And lucky for us, because u is x, we don't have to change our bounds. This is just going to be root 3 over 3. 4 is going to be right here. 1 over a squared plus u squared du. We know that that is going to be inverse tangent. And then remember that my formula is going to be u over a. So it's going to be u over a, 1 over a, from root 3 to 3. Now u, remember this is already in terms of u, so that's great. And now that a is 3, so I'm going to go ahead and plug in a 3 for a. So I get u over 3. Then my bounds are root 3 to 3. I'm going to use FTC. So now I have 4/3 inverse tangent of 1 minus inverse tangent of root 3 over 3. Now, depending on if this is an FRQ or MCQ, I'm going to go ahead and simplify this fully. We know that inverse tangent of 1 is going to be pi over 4. And then the inverse tangent of root 3 over 3 is going to be pi over 6. So our answer here, our numerical answer, would be this lovely thing right here. Alright, same thing for 13. We are going to think if I have to use inverse sine or regular u sub. If I were to do regular u sub, I'm going to get u to be that, but then du is going to be 2x. I don't have an x to cancel out, so here we're going to have to use regular inverse sine. A is 2, u is x, so then if u is x, then du is just going to be 1, which means that we have the same bounds. So I'll have the integral from 0 to 1 of 1 over the square root of a squared minus u squared du, and we know that is going to be arc sine inverse sine of u over a from 0 to 1. Now remember that a is 2, so I'll have u over 2 from 0 to 1. Use FGC. So we get inverse sine of 1/2 minus inverse sine of 0, and that right there is going to give us pi over 6. Alright, in the next video we are going to quickly talk about completing the square. So we'll need that for the next couple examples.